Here I'm going to review for your 3.1, 3.2 quiz. So when you look at number one, I would start on the left side because it looks like you have some distributing you can do. And whenever I see something right away that I can do, that's where I want to start. That way we don't have to guess about what we're doing. So we're going to distribute cosine. I would always distribute first, that way you don't have to distribute with fractions. But we do see that now we have two things being added, which is what we want, but they're not exactly what we want. So we're going to change things into fractions and see if we can cancel stuff. So cosecant is 1 over sine. I'm going to change that. And tangent is, if you look at your quotients, sine over cosine. So I'm going to change that. So that's cosecant. This is tangent. And then it looks like my cosines cancel, which is where I'm getting that sine from. And over here, cosine over sine is making cotangent, and that is because if you look at your quotient properties, cotangent is cosine over sine. So find that on your note card. Just to show my steps, that would be cotangent plus sine. And then we have what we wanted to prove. Number two, looks like we should start on the left because it looks complicated, which means we have a lot of stuff we can do there. And since there's higher exponents and we're subtracting something that looks squared, it's going to be factoring, and we're going to do difference of two squares here. This is a squared minus b squared, which factors into a plus b, a minus b. I'm splitting the 4 into sine squared, sine squared. On the bottom, we are leaving that alone. And we're leaving that alone because now we have a common factor that cancels. And then 1 minus sine squared, we need it to be cosine squared at the end. So if you look at your Pythagorean properties, if I were to subtract sine over to the 1, I would get 1 minus sine squared, which leaves me with cosine squared. So that is Pythagorean. Number 3, cotangent x cosine x plus sine x. Here I am going to change things into fractions because I've got two things that I want to come down to 1. When I look at cotangent, I see cosine over sine on my note card, so I'm going to change that into cosine over sine. I'm going to leave cosine alone. Then I'm going to combine those together, so that's cosine squared. Then it looks like I need to get common denominators so I can add these together. So I'm going to put a sign on the bottom of this, which makes the top squared, because you're putting a sign on top and on bottom. Now that they have matching denominators, you can add those numerators. Then we want cosecant at the end, so this is too much. So if I look at the top, I've got a Pythagorean property. Cosine squared plus sine squared is 1. And 1 over sine is reciprocal. 1 over sine becomes cosecant, and so we get what we want. So that is your number 3. Number 4, I'm going to start on the left side where we've got the secants, just because there's more we can do with secants than with cosines. So starting there with my given, I'm going to then change secants into 1 over cosines. Those are reciprocal properties. Why cosines? Because that's where I want to go at the end. I've got fractions and fractions, so I want to get common denominators on top. So I'm going to change 1 into 1 over 1, and then give it a cosine on top, a cosine on bottom. So that'll be cosine over cosine minus 1 over cosine all over this 1 is 1 over 1. If you give it a cosine and a cosine, you're going to get cosine over cosine plus 1 over cosine. Now we can combine fractions. So we get cosine x minus 1 over the common denominator. On the bottom, you have cosine plus 1 over the common denominator. Now we have one fraction divided by one fraction, which means you can take the top and you can multiply by a reciprocal of the bottom. Cosines cancel. And multiply by reciprocal of the bottom, so I flipped that, and cosines cancel, and you get what you want at the end. Number 5, I'm going to start on the left because it's got parentheses squared, which tells me to FOIL, and when I know how to start, that's where I want to start. So we're going to have secant x minus tangent x. We need to write that twice. That's what squared means. You cannot distribute a square. You have to write the whole parentheses twice. Now we're going to FOIL. Secant times secant, secant squared. Secant times negative tangent is negative secant tangent. Negative tangent secant is negative secant tangent. Negative tangent times negative tangent is positive tangent squared. Then from there, I can collect like terms. There's 2 of those. So 2 secant tangents. And I'm still nowhere closer to these signs. So I'm going to change everything into fractions now. So I'm going to change my secant into 1 over cosine. I'm going to change my tangent into sine over cosine. And then the squares are the same ones, just squared. So 1 over cosine squared. A 2, you can think of that as 2 over 1. Secant is 1 over cosine. Tangent, sine over cosine. Tangent squared, sine squared over cosine squared. And again, it's because it was nowhere near what I wanted. So I'm just totally changing the problem into sines and cosines. Now, if we see, we have a common denominator. Each of these fractions, there's 3 terms. There's this, this, and this. They're separated by plus and minus signs. They each have 2 cosines on the bottom. So that means I can put all of this together. So I have a 1 minus 2 times 1 times sine, which is 2 sine, and then a sine squared, all over common denominator cosine squared. If we look at where we're headed, I do have sines now, so that's good, but I need sine on the bottom, and I only need 1 sine. I don't want squared, so this is telling me to factor. So on top, this will factor. If you want to think of algebra first and take out the signs, you can take out the signs. You have a quadratic trinomial. If you want to put it in descending order, you want to find factors of 1. You multiply 1 and x squared, you get 1x squared. See factors of 1 that will add up to 2. Well, the only factors of 1 are 1 and 1. So you're going to have x minus 1, x minus 1, which then put your signs back in. So you don't have to separate it like this. You can go ahead and factor it right away if you know how to. But if you struggle with factoring, go ahead and change it into an algebra problem and then put the signs back in. Cosine squared, I want sines, so we're going to use Pythagorean. If you look at your Pythagorean property, if I subtract sine squared to the other side, then I'll have cosine by itself. So cosine squared is 1 minus sine squared. And then I need to factor that. This is a difference of 2 squares. So when you factor the difference of 2 squares, leave the top alone. And then we're going to split the bottom into 1 times 1 and positive sign and negative sign. And then when we look at the end, we want to keep this. So we're not going to mess with that. But I want to cancel this one. But these are not identical. They're flip-flopped. So what we're going to do is I'm going to factor out a negative 1 out of this. So I'm going to leave the top left alone, but on the right I'm going to factor out a negative, which is going to make the 1 positive and the sign negative. And then if I leave the bottom alone, those match now. So they cancel. And then we're left with a negative that we can move into the other factor, which would make that +1 and negative sign. And on the bottom, I have 1 plus sign, and that is what they wanted you to prove. You can start on either side for this one. I'm just going to keep on the left because that's what I usually do. And what I see is the conjugate at the end. So what I'm going to do is multiply by the conjugate and just see if it works. So we're going to multiply by secant -1, because that is what we want later. We got to do it to the top and the bottom, and we're going to FOIL. Secant times secant is secant squared. Secant times -1 is negative secant. Secant in 1 is positive secant, and 1 times -1 is -1. On the bottom, I'm not going to FOIL. I'm just going to leave them separated, because at the end, I want secant -1, and I don't want to mess with that. When I look at my FOILing, the middle terms cancel. And I don't want this tangent on the bottom. But if I look on top, the top will change into tangent squared. Because secant, if I subtract 1, I get tangent squared. So secant squared -1 changes to tangent squared, which allows me to cancel a tangent in the denominator. So tangent cancels, and we get tangent over secant -1, and that is what they wanted us to prove. Number 7. 7, you've got a complex fraction, so I'm going to make it worse by changing cotangent to see if I can somehow cancel things and get this fraction to look better. So I'm going to leave the top alone, leave cosine alone because I like cosines and sines, but cotangent, I'm going to change that into cosine over sine. Then on the bottom, I'm going to get a common denominator down here and see if that helps. So if I give this a sign, then that means I have a common denominator. I'm going to have sine cosine plus cosine over sine. So there's that. Then I've got something divided by a fraction, so I'm going to go ahead and multiply by the reciprocal. So you've got sine x plus 1 times, we're going to flip this one. So then there, I'm thinking I have this cosine in common that I want to get rid of. So I'm going to factor out that cosine. So on top, I'm just going to move the sign in front just because I like it looking in front first. And then I like parentheses second. And then here I'm factoring out a cosine, and I'm left with sine and plus nothing, so +1. And now those cancel, and we get sine over cosine, which becomes tangent. So this was kind of common denominators and some factoring. Is a sum of, or a difference of cubes, which follows this formula when you're factoring. So that's what we're going to do with our sines and cosines. And so I have factored the top and using this formula with sines and cosines. And then on the bottom, we aren't doing anything because these are just going to cancel out for you. And then if you look at what you need a 1 plus sine cosine. Well, we have sine cosine, and these are Pythagorean and make 1. So you get 1 plus sine cosine.